Okay, now we will go straight to the example 11.1. So right now we are learning how to transform simple functions. So the first simple function is ft equal to c. So c is a constant, so it has any value. So how to solve this is quite simple. We go back to the formula that we have learned. So we just put c at we replace c right here. Okay, so we will have this one. So c is replaced with we substitute the f function, and then we use this kind of function, the limiting case, and then we solve the integral. So we will get this form, and then we replace t and 0 inside this equation and minus both of them. Okay, so this is the outcome. So if you look at here, we can see that there's s right here, and that s can have a complex form like this. So we will have a real part and a complex part. Okay, so if you want to make sure that this component is converging, we need to make sure that this component is negative. When it is negative, for example, e is negative t, for example, we replace s with negative 1 or 1 only. So it will be e power of negative t. That means 1 over e power of t. So when we replace t with infinity, so what will happen is this one is equal to 0, right? So that is what we want to have. We want to this equation to converge into one value, which is 0. We don't want this function to have positive. So when it is positive, e power of infinity will be infinity. So we don't want it to be diverging. Okay. So we can replace this function. We substitute into s. So we will have this right here. So we can use Euler equation. This is the Euler equation. Transform it from this one to this one. Okay. So from there we can see that this is the function, the component that will decide whether it diverging or converging. So we can have this condition. This is the we call it the condition that we must obey, so that the Laplace transform is applicable. So the epsilon should be, or the real part of the s, this one, should be bigger than 0, so that this function will converge. Okay, hopefully you understand that. So when we decide that, when we have this condition, okay, so it means that the function is converging. and this component is equal to 0. The exponential is equal to 0. So what will happen is, we go back to here. Okay, hopefully you can get where I'm pointing right now. So when this component is equal to 0, so this function is equal to c over s, right? So we get c over s right here. Okay, and the condition is this one. So this is the final answer for example 1. Okay, so that is when the function is a constant. Okay, now we go to the next example. So in the next example, the function is slightly different, but the type is different. So right now it is equal to t. So what will happen? Again, we replace t inside the function right here, and then we put this kind of equation, the limiting case, and we solve the integral, and then we want to analyze how to make sure that this function is not diverging and it is converging. So we need to make sure that we find out that this the epsilon, the real part of s, should be bigger than 0. Okay, so this function and this component, it will be equal to 0. So this is the one that left. So that is the answer, the transform equation with this condition should be obeyed. Okay.